GAC, what is up? It's Coach J. 2.4 is what we're looking at today. Hope you're doing well. Hey, I have noticed that a lot of you have been up to date on your homeworks and everything's looking good. Make sure you continue to do that. Make sure you, if you need to, come to those podcast sessions, get those questions answered. The second podcast that we're going to have is on Wednesday. Some of you may be watching this on Thursday, so it might be too late, but you can actually go back and watch those other ones as well. Understand that next Monday, we're going to take some time to be able to just work through any questions that you have, anything that you need, all right, any details there. But make sure that these podcasts you are responsible for. So for some reason, if you or maybe some of your friends right now are thinking about doing something different, it would be in your best interest to really stay up on the material there. Okay? All right, let's get it underway. I want to look at today section 2.4. This one is one that a lot of people may struggle with just because it's maybe you saw it in Algebra 2 or whatnot. I've always sensed that it becomes a little easier when we do long division and synthetic division. For students, it's a lot easier the second time around and even sometimes the third time. So in getting into the division of polynomials, let's say that I'm trying to find this long division. If I were to go x minus 2 into 6x cubed minus 19x squared plus 16x minus 4. So my question is what times x gets me to 6x to the third? We know that would be 6x squared. So once I multiply 6x squared times each, I would get 6x to the third minus 12x squared, okay? I'll then change the sign. I would cancel out that first value. So let me stop real quick. Just like in any division, what times x gets me 6x to the third? Well, we know that that would be 6x squared, so that's why I put it, remember, look right here, I put it underneath the x squared, the one that's in common, okay? Then I distribute to each. So 6x squared times x, 6x cubed, try to say that 30 times fast. 6x squared times negative 2 is negative 12x squared, but I changed the signs in order to cancel these out. As long as I do it to both, I'm fine. Negative 19x squared plus 12x squared gets me negative 7x squared. So I've got that. As I bring that down, okay, I then bring down the next one. So I add 16x here. Now my question is what can I put here that when multiplied by x gets me to negative 7x squared? Well, I keep the sign and I just take away an x. So I have negative 7x. Now just like before, I'm going to distribute to both of these. So negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. I combine to where I change the sign, change that one. This would be a negative. This one cancels, getting 0, okay? 16x minus 14x now gets me 2x. Now, as I look at this, the only thing that I have left to bring down is that minus 4, to where then I ask myself, what times x gets me to 2x? Well, there's only one thing, and that's positive 2. So if I take that 2 and multiply by x, I get 2x. And if I take that 2 and multiply by negative 2, I get negative 4. I then change the signs like I did last time, cancel, to where my remainder, r, would be 0 there, okay? You can also check out the podcast on the website, algebra3gac2.weebly.com. Check out 2.4 podcasts. This goes over a little bit more. I believe I did this one here. Just to kind of go through it, make sure on this, check that podcast out because on this one, it doesn't have x to the third. So you're going to have to add 0x to the third as well as a plus 0 on the outside because my highest degree must, and you see it here, it must decrease by 1 each time. So 3, 2, 1, and then there's nothing. So if I were really rewriting this, I'd do the same thing I did before. But that x minus 4 would go into 4x to the fourth minus or plus 0x to the third minus 4x squared plus 6x plus 0. And so again, that's kind of what we're looking at when we do it. What times x gets me 4x to the fourth, and we do the same process as we did on number 1. Again, I did that on the podcast, so check that out moving forward, okay? All right, now on this one, we've got to understand that it's the same exact thing. Now, there is a little bit of a difference because now we have 3, but we're still setting it up the same. x squared plus 2x minus 3 is going to go into 2x to the fourth plus 4x to the third minus 5x squared plus 3x minus 2. Again, make sure for my highest degree or my highest exponent, it must decrease by 1 each time, and it does that. So we don't have to add any 0x's or 0x cubes or anything like that. So my next question is the same. Okay, get this here. What times x squared gets me 2x to the fourth? I want you to yell it out right now. All right, Rhombus, very good. Nicely done, Rhombus. Coming back from City of Children. You're exactly right. 2x squared times x squared gets me 2x to the fourth. So I'm going to put 2x squared right here. Now, as I multiply this, I'm multiplying by each of these three. So 2x squared times x squared is 2x to the fourth. 2x squared times 2x is 4x to the third. 2x squared times negative 3 is negative 6x squared. And we're headed towards being done a little bit better here. We changed the sign of all three of them. Again, I can't just do it to one. I got to do it to all three. To where this one cancels, and negative 5x squared plus 6x squared is just x squared. Now, because there's 3 on this side, we must have 3 down below. Notice, in the case of the previous one, we had to have 2 each time. 2, because of the fact that there were 2 different expressions, 2 different values on the outside, okay? 2 terms. So we're going to bring down the 3x and bring down the negative 2. My question now is, what times x squared gets me x squared? Well, the answer should be 1. It's kind of weird, right? Because you usually have something in there. But if they're the same thing, you just put 1, because 1 times x squared is x squared. 1 times 2x is 2x. 1 times negative 3 is negative 3. So we change the sign to negative, negative, and positive. This one cancels. 3x minus 2x is x. Negative 2 plus 3 is positive 1. Nothing left. There's nothing left to bring down, right? So you could either do this one of 2 ways. You could either say remainder of x plus 1, or better yet, let's put plus x plus 1 all over whatever's on the outside. So x squared plus 2x minus 3 would be my answer, okay? Again, hopefully that helps you out there. That's kind of what we're doing. Now, what if we went to a second one, such as synthetic, okay? We're going to do this synthetic here. Again, just like before, if I were doing this one, I do x plus 3 all divided into x to the fourth plus 0x third. Remember, notice I put that 0x to the third in order to hold that spot, right? So make sure you do that on your homework too on that MML, okay? So this is what we would be dividing into. But let's say that we didn't want to do it this way. We want to do it, let's say, a quicker way. And that's what we call synthetic, okay? Now we have 2 things. Number 1, we have a magic box that we have to fill in, as well as the coefficients across next to this magic box here. So the number that goes into this magic box is actually what can be plugged in for x to make this equal to 0. The answer, negative 3. Okay, it's a little different. So what can I plug in for x to make that equal to 0? Negative 3. Now, as I look at this, the coefficients in the front must be labeled next to the negative 3. So this would be 1, 0, negative 10, negative 2, positive 4. Okay, and you really have to put positive, but just 4. So here's how synthetic works. Again, the coefficients next to the negative 3. The negative 3 comes from what plugs in for the x plus 3 to make it equal to 0. So my question now is, what do I do with the first value? Well, this is the only one that I have to do this for, but I bring down the first value. Then the negative 3 and 1 are multiplied together and put next to the next term. 1 times negative 3 is negative 3. I add 0 and negative 3 together to get negative 3. I then multiply. So negative 3 times negative 3 is positive 9. I add together here. So I multiply to get to the next value, but then I add here. Okay, negative 10 plus 9 is negative 1. Do the same pattern. Negative 3 times negative 1 is positive 3. Negative 2 plus 3 is positive 1. 1 times negative 3 is negative 3. And 4 minus 3 is positive 1. So here's how this will work. Once I put these values here, I have my remainder, number by itself, the number that goes with x, the number that goes with x squared, and the number that goes with x cubed. It always follows that order from right to left. So I can write it this way: 1x cubed, or just x cubed, minus 3x squared, minus 1x, or just minus x, plus 1, remainder of 1. Okay, you could write it that way, or you could write it x to the third minus 3x squared minus x plus 1. This is really the better way. Then plus 1, that's the remainder, all over the x plus 3. Okay? Either of those I will take, but that's kind of the idea. Again, bring down the first value, multiply here, then I add. Multiply, add, multiply, add, multiply, add until I get to the very end there. Remember at the end, remainder by itself, x squared, x cubed. So be careful on that. Make sure you go accordingly. Okay? All right, you could try a couple of these as well. And this one is where you could kind of solve the equation. Or if I say -1 is a root and 0 is the same thing. So in this one, I could actually, I don't have to change the sign, because in that one, it gives it to us. Whereas in, let's say this one, the magic box would be 2, because we have to change that sign. Whereas with this one, since they give it to us, we could put -1 in the box, and then we can label it 15, 14, -3, -2, and really that's it, right? Well, once I get from here, what I can do, kind of push forward, is if I'm trying to solve this equation and I know -1 is a solution, I bring down to 15, then I multiply. 15 times -1 is -15. 14 minus 15 is -1. -1 times -1 is 1. 1 minus 3 is -2. And -2 times -1 is +2, to where this would be 0. Now, if this is 0, that means my remainder is 0. I have it by myself, x and x squared. So it really is 15 x squared minus x minus 2. And right there, that's actually what my answer would be. But in this case, they want me to actually solve this equation further. So I could actually take this and factor it a little bit further by saying what two numbers, when multiplied, get me 15, and I'm trying to think, probably 5x and 3x is what I'm guessing. Because then if I can do what two numbers that multiplied equal -2, I could do like -2 and +1. I think that'll work right there. So right here, this would actually be this factored here. Set it equal to 0, right? Remember we talked about that the other day. Set them both equal to 0 to find the roots or the zeros or the x-intercepts, all the same thing. I then add 2, and divide by 5 to get 2/5. And on this one, I subtract 1, divide by 3, and I should get -1/3. Okay, we'll look at that a little bit more on Friday, but that's kind of the idea of what we're looking for. Looking for when we're finding the roots. Or again, all three of these are the same: roots, x-intercepts, and zeros. All three of those are the same thing of what we're referring to when we talk about solving equations, solving that sort of thing. Okay. All right. Hey, again, hopefully this was helpful for you. We will look at this again a little bit more on Friday, go into a little bit more detail. But before we go, reminder, make sure all of the homeworks you're up to date on, especially those hard copies. If you have a couple questions, we can look at those, but I'd like for you to complete those as much as possible. And then also, these podcasts should help you, as well as the podcasts at night as well. All right. Thank you so much. Hope you all have a great day. And we'll see you all on Friday. All right, bye now.